Now, look at the headline of this class today, Analysis of Rectilinear Motion by Calculus. Now, some time back we did a lecture whose topic was Graphical Analysis of Rectilinear Motion. And if you remember, we had there discussed a particle moving in a straight line and had learned to draw its position time graph and from there velocity time graph. Let me recall that with some figures. So as you can see here, we considered the motion of a particle moving along the x-axis. So I took, this was my origin, this was my taken to be the x direction plus x-axis, and here is a body, and its position with respect to the origin is changing. As you can see, at initial time t1 its position was, coordinate was x1, the later time t2 the position became x2, and so on, all measured from the origin where x is equal to 0. At all intermediate points here onto this path, we can find out the position x of the particle as a function of time, and or we can have some data that gives me the values of x and t, and by plotting this data we could have a graph of x versus t. See, t is along the horizontal axis, x along the vertical axis, x is a function of time, and that is called the position time graph of the particle. We have done these things. We have done further that at any given instant during this motion, if I wanted to find velocity, I just need to take the time into consideration, draw a vertical line parallel to the x-axis, x that is vertical axis, and where it cuts that given graph, that was the green line here, draw a tangent to the graph at that point, and the slope of this tangent gives me the velocity vector. So if you recall, the velocity, well, let me show just one example what I did here, just extending this tangent line here and measured the angle made by this tangent with the t-axis, letting me call this as theta. The slope of tangent is coming out to be m, that is tan theta. This represents graphically the velocity of the particle at that particular point, instant, and that is written in calculus language as dx dt, derivative of position with respect to time. This is the way you could find out velocity at every single instant of motion of the particle and could draw my VT diagram, velocity time diagram. We call it xt, that is position versus time, then VT, velocity versus time, and the logic is very simple. You get the value of V at every single instant by finding slope of the tangent, and that is the value of the V here. Make another table and plot the graph, that is VT diagram. And then again in this figure, if you could have drawn tangents similarly at any given instant, I could just draw the tangents at t1, t2, t3 in the similar manner, see where the line drawn vertically from any given value of t, it cuts this green line, the curve v versus t, and drop a tangent there and see what is its slope. Like for this example, let me see this particular case. I measured the angles like this. This is my angle theta, and again the slope of this line m is coming out to be tan theta. But in this figure, v versus t, this is acceleration of the particle, that is dv dt, derivative of velocity with respect to time. So you have done similarly. In both cases, from position time graph, I could find velocity and could plot a velocity time graph. And similarly from the VT graph itself, by drawing tangents at different instants and finding a slope, I could also find an acceleration time diagram, whatever be its shape. So we have learned how to go from xt graph to the VT graph and then from to AT graph. The question comes, is there a method, a process in which if the AT graph is given, say, if I'm giving this AT graph, can we from here plot the VT graph? And then again from the VT graph, can we plot the XT graph? For a particle, of course, moving in a straight line. And the answer of this question is yes. This process we discussed earlier is finding derivative. This is a part of calculus called differentiation. But what we shall learn now, the process of going from AT diagram to VT diagram and then from there to xt diagram in the reverse direction, that involves a process called integration. Let me write that name. This is going to teach about integration in this session, and that process is the reverse process of differentiation, and both of them fall within the realm of calculus, as we shall see in the class.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.